the colloquium, the recording. We will record this session, and we also try then to put it as a video on our ZALF platform. And that is really nice also for those of you who are interested also later on. Let also your colleagues know that we have a video from this talk today. Yes, Michael, Michael Obersteiner, you're a professor, you're the director of the Environmental Change Institute of the University of Oxford. And I warmly welcome you, and it is really nice to have gained you here for this 1.5 hour slot. And this is really nice. Your today's talk, we agreed on this beforehand. How productive is a land sharing sparing discussion? And I'm really eager to learn also on this topic. I would not use now a lot of time for introduction, but maybe very, very briefly. We know each other personally since 2007, I think so. It was in the census time, and from time to time we meet, and we always said, let's do something together. Let's start a cooperation. And we are very happy that you are also a ZALF fellow. That means that we also try to build a cooperation also for others here in the chat. Please, that you should know that we try to cooperate with the ECI and in Oxford, and that you should also, if you are interested to cooperate on land use issues, land use modeling, that you can also come to me, that we try to organize something in this regard. You're a professor, your experience is really, I would say, outstanding. It stretches from biophysical modeling in the areas of ecosystem, forestry, and agriculture, towards economics, finance, and integrated assessment. That makes also your experience very unique, yet you have also this monetary view in your analysis, in your research. And of course, you cut across today now of all topics in the ECI. You were, and I always linked you with the IIASA, with the International Institute for Applied System Analysis, and you developed there also the ESM program. That is a program you were are the director of the Ecosystem Services and Management program at IIASA, and you're still very much affiliated to IIASA, I would say. And you joined there in '93 in the forestry program, and you were developing this ECM program. And well, by training, you studied in Austria, the Boco University and the Institute for Advanced Studies in Vienna, and on the terrestrial ecosystems, and having completed also there the graduate studies. And I will also tell the secret that, of course, you were in New York, and also astonishingly, I was astonished myself, in Novosibirsk and in Russia, the Russian Academy of Science, where you studied. And that's also quite interesting. It's a unique selling point, I would say. But I don't want to steal now your time, but I hope also that we have a lot of following up discussions on a closer cooperation between ZALF and ECI. That would be really, I hope it will be a win-win situation. And with this, I'd like to give you the floor, and again, welcome and thanks for having you here for the next 1.5 hours. Okay, Michael, the floor is yours.
Thank you, Stefan. Yeah. No, it's really a big pleasure to talking to a friend and many future friends at ZALF. And for sure, we will be able to collaborate quite a bit. Just for your information, we are starting a new, very large initiative on nature recovery as well. with here in the UK, but then also at many overseas locations, ranging from Ghana, Peru to other places. So that's something which is quite important these days, because we are in the decade of ecosystem restoration, you know, the United Nations decade. And probably with this, I can immediately dive into this land sparing, land sharing presentation. Just to start out, as I said already, this is a topic I actually never wanted to really go into, because it's such a busy area, and my research strategy was always to do something that you know, is not topical now, but might be topical in 5 to 10 years from now. But I could not resist, also because it's so ideological, and at every kind of policy meeting you're in, you can actually say this is a land sparing person, this is a land sharing person, and there's a lot of historical and ideological baggage that comes with these two positions. So let's have a little bit of a closer look at it. Just as I will go through the presentation, I intentionally have put in a bias for land sparing. This does not mean that this is my true opinion. This just is designed in such a way that I want to stir up a little bit of a controversial discussion. So let's see how it goes. Let me first start with the observation that you know, agriculture and the nature sector is a giant and highly underappreciated in policy discussions and so forth. You know, when we talk about solving the climate problem, everyone talks about traffic problems or shutting down power plants, but as depicted here, it's actually the AFOLU sector, so agriculture, forestry, and land use, is actually one of the largest greenhouse gas emitters in the world. And when you take, which is also quite interesting, the food system as the boundary, the calculations go up to 37%. So the food system in itself is at least 1/3 of all greenhouse gases. But then, of course, it's on a global level, the nature sector overall was estimated by the World Economic Forum to be at least 50% of GDP. And there again, the food system definition is quite interesting. And I ran across a study made in France, where France calculated that the food system GDP contribution is actually 36%. So again, here we are talking about 1/3 of the total economy is actually attributed to the food system. But then globally, it's for sure the largest employer. So we have, well, there the estimates go into many directions, but FAO says there are about 1 billion farmers, depending on how you calculate full-time equivalent or not. But then I put into brackets the 2.5 billion household dependents that go with the farm household. And here again, this is again a third or even more of total population. But then it's also, when you go into the details of it, there are numbers. It says 65% of the working poor depend on it. It's the largest source of child labor, and so on. At the same time, and this is the figure here I put there, this is World Economic Forum 2020, that they have updated ones, but I like this figure better. And when you just look at, you know, high likelihood, high impact, it's all related to the food sector. It's climate action failure, extreme weather, biodiversity loss. So these are all of the big systemic risks that the world faces these days. And we're just coming out of COVID, and many forget that COVID most likely originated from natural ecosystems, which were mismanaged, partly for agriculture. Okay, and we can go on and on, but that's not really the topic. I just want to say we are actually, ZALF, if you want, is working on one of the hottest topics about the well-being of current and future humanity. So let's quickly go into this land sparing, land sharing. For those who are not fully into this discussion yet, land sharing is basically here, it's wildlife friendly farm management with the addition that you actually have more of a diffuse landscape. So you do farming everywhere, but you do it in a more responsible manner, if you want. Land sparing, on the other hand, basically tries to divide up the landscape into natural habitats and very high yield farming, where the higher the yields you attain on the high yield farmland, the more land you spare and can give back to nature. That's the basic definition, I would say, technical definition of land sparing and land sharing. However, land sparing and land sharing take on many different forms. So here, for example, you have this, and probably quite many of you have seen this study on an agroecological Europe in 2050, where it basically makes the calculation of abandoning pesticides and synthetic fertilizers altogether, and really going into extensive grassland production and see this as a landscape infrastructure. So this agroecology really very strongly implies land sharing. And I just picked out a small little detail. In this case, in these scenarios, there are diet shifts, but the diet is not at all vegan. And the recommendation is to go for red meat, because grazers are actually very important to concentrate some of the nutrients which you need for the nutrient cycling. So here, even on some of the details, it's the recommendation going towards red meat consumption is inconsistent with quite many things you hear these days, but it makes sense. So just to mention this little detail. Overall, we have, if we open up the discussion, we have, and you see this in many meetings these days, you have people who really support the ecological critique, where basically modern agriculture jeopardizes ecological services through monocultures. You have irrigation, but also freshwater pollution. It's heavy on fossil fuels. And of course, it uses chemical fertilizers and pesticides. And you have an entire baggage of social consequences that come with this ecological critique. And this is basically subscribing to an image of land sharing. However, you also have the techno-productivist approach. I'm currently in a workshop here in Oxford with IFPRI, and those probably really have pushed the techno-productivist approach for quite some time, at least in their analytical works. And this is mostly led by economists. And here, the recommendation I will go into more detail is really, you know, invest more into agriculture R&D, produce in a modern way with the best agronomic practices. And if you do that, then you basically have a growth engine where through more mechanization, you push out labor into more productive sectors in the economy. So this is really the techno-productivist view, and if you and fully subscribing to land sparing, and if it's nowadays more this kind of view is cast in a more greener setting, then the conclusion typically is go vegan, change your diets, or if you eat, then you need to eat white meat. So even there, you know, you have the land sparing before the land sharing argument before, where you actually should eat meat from grazers. Here you would actually eat from chicken. Good. So just coming back to this economic growth narrative, which basically is rooted in everything we have seen in terms of economic development theory after Second World War, where basically we have this idea that agriculture is a low productive sector in the economy. It's associated with lots of poverty as well. You have many uneducated people. The household budget doesn't allow to send children to school properly. It's unorganized, it's informal, it's inefficient. And on the other hand, you have the modern economy defined by capital accumulation, high education, and lots of formalization. So basically, the idea, and this was, you know, the mainstream and still is the mainstream policy of, you know, many of the economic organizations like World Bank, but even overseas development agencies many times transport this kind of narrative where you want to get labor out of the agriculture sector, get people into the more formal, higher earning parts of the economy. And this economy gives back modern technologies and inputs to the agriculture sector. And here you have you know, the mantra of technological progress. You have do more genetic engineering, do the better everything that has to do with agronomic improvement, basically higher yields in the end. But then the narrative goes in addition. You have you push for education, you push for accessibility in terms of infrastructures, you have formalization of markets, and so forth. In all of this discussion, maybe I don't go through these details here. It's basically repeating with in the field of development economics, new structural economics, neoclassical growth theory, but also in classical agricultural economics, you see a repetition of all of these arguments. And I would say most of the development money in these days goes in accordance to this paradigm. There is also quite a lot of historical evidence that these things, it's kind of almost described as an economic law, if you want, where the more development you see in terms, you actually see here on the x-axis, you see value added of agriculture in the economy, and on the y-axis, which is here on the right, is employment, and you see all of these countries going up into the right corner where the OECD is sitting, and which is described by a very low share of employment in agriculture and a very low share of value added. If you take this narrow definition of agricultural production, as I said at the beginning, if you do the food system framing, then you end up with much different GDP numbers. So here one needs to be a little careful. But overall, the narrative is we actually want, or we are gravitating naturally through economic development to the top right corner, which is basically a world without agriculture and farmers. And you see different speeds. But when you go into other details, and here let's look at this figure at the bottom, where we have labor productivity and economy-wide labor productivity. What you see here is there's a strong tendency of all nations, more or less, to really go through this U-shaped curve, again, where you have in this case, a widening between income of labor in agriculture and in the rest of the economy, the modern economy. And at some point, and this big bubble there is India and China. We are really standing in front of such a major transition where China actually is going towards very heavy urbanization and transitioning the entire economy into a industrial and service-oriented economy, and has very strong and proactive labor relocation programs, where, for example, in a country like India, there's much less planning, and also due to a more prevailing land sharing narrative of the policies, with very strong incentives to keep people still in the rural areas. However, if you look at this as a kind of an economic law, it's actually almost impossible to run away from it. But now let me go into the discussion of land sparing and land sharing, and this will become a little more technical, where we basically wanted to calculate what are the consequences if the world, in a theoretical kind of setting, if the world would go for maximum land sparing, this is this MLS scenario, or into what we call targeted land sparing. The maximum land sparing, what it does, very simply, you have here in this picture, you have to the left upper corner, you have current yields. On the right-hand side, you have production possibility sets. So basically closing the yield gap. And then you have, after optimization, we have then the different manifestations of land sparing. But maximum land sparing, what it basically does, it prescribes an agronomic practice that maximizes yields and locates crops at a location globally where you attain the highest yields. With this targeted land sparing, what we basically did is we put in a restriction that we do land sparing, but only within countries, such that we basically maintain current trade patterns. Because the implication of maximum land sparing would be that most of the agricultural production would go to the main bread baskets, if you want, because you have that globally the highest yields there. And quite many countries would give up agricultural production and would engage in trading of food products. Very quickly as a background, in order to assess the potential yields, we used in this study biophysical crop growth models. I know ZALF is also very engaged in this. Basically, what you do is you gather all of the global soil information, you drive the model with weather, but you also look at the hydrological cycles, you look at the nutrient cycle, and you prescribe different management operations. So in this case, for example, we prescribed optimal fertilization rates, and we prescribed more or less 100% crop protection packages. So this is basically simulated on the field scale. What we did, and this is still work I did with my colleagues at IIASA quite many years ago. Now almost two decades, where we built a computational infrastructure where we also have gathered most of the best available global data in order to do a gridded crop modeling approach, which is depicted here. I can go in more detail later on if you're interested. What's currently happening, and this is for some of those who do the modeling these days, is to run these models is very cumbersome because you have to go into lots of details. You need to do a lot of manual work. What we are currently doing a lot is we use machine learning approaches to emulate this crop model, but many other crop models. And we use additional observations like field trials and so forth in order to come up with, let's call it a little bit of a hybrid emulator model, which runs much faster, and you can also investigate more management options and so forth. So this is something we are using these days also quite a lot. And then before we do the land sparing, land sharing optimization, we actually need to simulate these models out for all of these agronomic practices. And here I just have two dimensions. One is irrigation and the other one is fertilization. And we just, in this case, I think it's wheat. We model out wheat on a global scale for these different fertilization and irrigation regimes. But there are, of course, other dimensions to crop management. And we call this HyperCube. So this goes then, these simulations go then into a large database. And later on, we use this for modeling of integrated assessment. So these are these models that make these projections out to 2100 for IPCC, but nowadays we also run for biodiversity, for IPBES, and all of these other things. But what you can also do is you can directly optimize just on the biophysical side, which we did in this study. And here, these are the results now. So you see the cropland area on the very left. You see status of physical cropland extent between 2011 and 2015. You see we have stacked up the different crops which we modeled. This is about something like 85 to 90% of global crop calorie production, if you want. And then you see the next bar in the middle. So this is the simulation of maximum land sparing. So again, we close the yield gap and we locate the crops at the best location. And you see as a result, we get at least almost 50% reduction. So basically saying if we close the yield gap and locate at the best sites in the world, and this is just for crop production, we can halve crop production. And of course, when you look at the yield gap on grazing, areas, which are these enormous amounts of land, the land sparing is, of course, even larger. And we have some calculations done now where we substitute grazing land with, producing feed on cropland. And it suggests that if we were to shift to, again, in a more radical scenario, if we were shift to still produce all of the meat we produce and more or less give up to a large extent grazing, we would still get cropland sparing, even though we would produce all of the feed that substitutes for the grazing. So that's quite interesting. So that's basically an approximation of the technical potential that's sitting out there today. What was also quite interesting, and this is the bar to the right, is this targeted land sparing, where we basically maintained the same amount of food production, but just closing the yield gap in country. And the land sparing effect is almost of similar magnitude. So here we have this 62% of land sparing, meaning that even if countries globally just keep on producing the same amount, just closing the yield gap would bring us to such land sparing, which is quite amazing, I would say. Then what we did is we looked at some of the environmental consequences. So and this is here for the maximum land sparing and the targeted land sparing. Well, sparing is probably it's the right kind of word. So what we see here is we use almost the same amount of fertilizer, depending on what detailed assumptions we make. In addition, we actually get even less fertilizer consumption. And here, this is due to the fact that, yes, you actually apply more fertilizer per hectare, of course. However, due to the land sparing, you multiply it with fewer hectares, and it cancels out, or even you get a positive effect. However, one needs to say we did not look at local pollution issues. This is something we are currently looking at. And still needs some investigation. What we see is that there is huge amounts of irrigation water sparing. So here we don't, in this maximum land sparing, we actually made this prescription that we don't use so much irrigation water. So this is about half. Then what we see is, of course, there is much less direct deforestation and devegetation happening in such a scenario. And even on the non-CO2 greenhouse gases, we actually see a sparing effect. We also ran a habitat for small range species biodiversity model. And given those results is that the effects were about neutral, and for the targeted land sparing, you would actually see some of these, mostly birds, suffering from it locally. However, not to such an incredible degree as we originally anticipated. However, there are many caveats. What we did not do in this study, looking at kind of scenarios where on the spared land you would actually do major restoration efforts. This is something which we are currently doing with Martin Jung, and I just put this slide there. So if some of you are interested to participate in such studies, we could discuss. So this is also just currently in the making. I'm just flagging it. And this goes very much into, land sparing and major major nature recovery activities. How can we get this done? So now I would like to go a little bit into the economic dimension of land sparing and land sharing. And again, I'm talking more about land sparing here. And hopefully in the discussion we can go more into the other discussion of land sharing. What we see from basic farm economics is we see economies of scale, which means that if economies of scale are not counter, if there are no counter forces like in European agricultural policies where you get, you know, decoupled payments, a farmer, due to economies of scale, at some point will be taken over by a larger farmer, and you will see consolidation in the farming sector in terms of farm enterprises, but you also see this consultation in landscapes in terms of consolidation and concentration of fields, and in the end on larger scales in the larger bread baskets. What we also see, which is important, is a concentration in the input industry. We have developed an industry, a fertilizer industry model, and we see there that this trend will continue. We will see more concentration in nitrogen, phosphorus, and potash for sure. We see similar tendencies in the machinery sector, and of course, when you look already at the concentration of seed companies, and especially animal genetics, for example, there you have a concentration of almost. There's basically just one actor if it comes to chicken genetics, for example. The other thing which we are also going to see more and more is economies of scope and horizontal integration. So where, for example, industry players like machinery companies might merge and already do cooperate with fertilizer industry, but then also with plant protection and so forth. We will definitely see this kind of horizontal integration. And what we will see more and more also in poorer countries, a quite fast penetration of supermarkets, retail, and so forth, all of which will give a massive boost to mechanization and farm consolidation, which we have seen in most of the advanced economies. I also want to flag is more and more we see digital farming coming along. We also see vertical farming, especially in the leafy green sector. And if you have seen, we are really standing in front of a major biotech revolution, where you have companies, even in my home country in Austria, there are 2 startup companies who produce protein from air, basically through renewable hydrogen. So there's a lot happening and will be happening. And for me, the question is, how can we still support some of the land sharing paradigm to actually make this transition to all of these kind of things, which are where there's strong economic momentum behind it. How can we make this transition less painful? One argument also of the techno-economic, more economist-driven communities that we have seen since World War II more or less a steady decline in food prices. And so if we were to do more of this mechanization and capital intensive, resource intensive farming, what would this mean in terms of costs, and then thereby long-run trends in food prices. So what we did here is we built a techno-economic cost accounting model. I don't go into the details. It's basically it's farm economics, if you want, so where you really go into the pricing and costing out all of the inputs, starting from seeds, fertilizer, and so forth. And it's basically coupling what we have seen before with the crop modeling, where you describe when you seed, when you harvest, and so forth. And all of these things are costed out, including the fixed cost elements in terms of machinery, buildings, and so forth. What we do not do yet is, and this is also under construction, is costing the land. So basically land pricing. And once you have a techno-economic model up and running, and you combine it with the crop growth model, you can actually go into full geography. So in this case, this is something we did for Brazil, where we just planted soy everywhere where it could grow, independent whether it's cropland or forest land or whatever. And we just modeled it out and constructed then the costs. And what you can do is you can build then these classic economic supply curves, where you have cumulative production on the x-axis and the cost per ton on the y-axis. And what you see is when you go through all of these exercises and you repeat the land sparing exercise, which we have seen before in terms of closing the yield gaps, but you just do the associated cost accounting with it, we see that land sparing gets us to very similar orders of magnitude of cost reduction. So we have about 40% cost reduction for the maximum land sparing scenario, and about 35% for the targeted land sparing. So even here, it's you have kind of the superiority in terms of cost competitiveness of this land sparing paradigm, which is very hard to beat, and you can only beat it through active intervention from governments, mainly through subsidies. So basically, you know, this gap you see here must be filled by subsidies in order to maintain current production structure in terms of farm structure. Of course, you can also go then into all sorts of fancy modeling, where we just look at here a geography of potential areas where the cheap farms would overtake the currently more costly farms. And what you also see here is, and I'm going fast, I apologize, you have here these supply curves. And what's really important here is, and I put this out on the left, is, so the business as usual cost is really way more expensive than the targeted land sparing. And of course, you have the lowest cost for the maximum land sparing. And the differences between the two land sparing scenarios are very small. So in that sense, it also doesn't really matter where you do this closing the yield gap in terms of the costing as well. What's very important is when you look at these supply curves, is they are much, much flatter. So this means that overall, you will see much, much lower prices than we see them today, because commodity markets still do marginal pricing. And so it's actually the last producer to the right is actually setting the commodity price market. And if these curves, these green curves, are flat as they are, then you can expect that we get quite massively lower prices, even larger than what we have seen with the the cost accounting in terms of percentage reduction. What we also see is that, especially in the maximum land sparing, and we overlay this with climate risks, we would also see less shocks. However, you have there, if then all in a sudden, due to unpredicted climate change, you happen to have a shock in one of these then larger bread baskets, this would have really detrimental effects. So here, this concentration currently, according to current climate scenarios, actually looks good, but I would highly caution this. So the next dimension we looked at is what kind of consequences would we see on the labor market? And what we found is that under maximum land sparing, we would only need 20 million farmers. And remember, depends how you count. If you take full-time equivalent farmers, we have about 500 million farmers. And if you take part-time into account, the numbers go up to 1 billion. However, if we were to produce everywhere most efficiently with current technology, so here we don't even prescribe the autonomous tractor, we would only need 20 million farmers, which is a super tiny fraction of what's currently out there. And of course, you know, if capitalism, as it prevails today, this transition could go very, very fast, especially in countries like India, but also many African countries. Because, you know, as I said before, if we see the supermarketization, if we see the input industry coming in really massively, and we see the finance sector capturing some of the risks and actually be able to capitalize agriculture in many of these countries where you see large yield gaps, we might see really large amounts of farmers exiting the labor market. So this is for me probably the single most important issue we really need to watch out is the social dimension of land sparing if we cannot avoid it. And so maybe I skip this one. This is not so important. I come to this back anyhow. And before closing, I still want to go back to this land sharing idea, which is way more labor intensive. And here this is of Navin Ramankuti's group, a publication where you actually, you don't need to have highly mechanized agricultural production systems in order to get the high yields, to get the land sparing going. And you might also get through more labor intensive production, but mainly these are specialty crops these days, more biodiversity. So for sure, there will always be, even if land sparing wins, there will always be a good niche and good reasons for smallholder farmers to still exist and actually contribute. And I think this is where much of the proactive policies need to go. If a country realizes this transition to more mechanization and the like, is actually triggered. So here, proactive policies on the social side and also on the education side and so forth are really, really, really important, including also targeting some of the more labor-intensive production systems. Good. So here again, just to conclude, I'm not necessarily in favor of land sparing. However, if you ask me about making a prediction which is actually going to materialize more, it's actually the mechanization, the capitalization, and the continuation of the paradigm which we were riding since World War II, unavoidable almost. And I would also say that because I'm looking these days quite a lot into these new biotechnological revolutions, which really might completely change how we mass produce food. This is something that is also necessary to co-think in these kind of transition pathways. Maybe to the third point. I'm sitting in so many unproductive discussions many times where people do not appreciate, the beauties of the land sparing, and on the other hand, the beauties of the land sharing. So, for example, I eat mostly organic food myself. I'm not so, for personal health reasons, but also to some degree for environmental reasons, also knowing that they come out of high yielding farms. And so here I think we need to have more open discussions, because most of the discussion, either you sit in this camp or you sit in the other camp and you actually don't talk across. And this is not only land sparing, land sharing, but it's actually the larger ideological package on, on neoclassical against newer type of growth discourses, including degrowth. And here, I think what we need to do is we need to do way more experimentation. And I think current, the fully chemical type of agriculture which we have today is absolutely not sustainable. And agriculture needs to become way more smarter and informed to do it right. So just look at crop protection. That this is rather primitive what we do these days. And if we were doing it in a smarter and a more biological way, understanding better the biological mechanisms and exploit them, we would actually get many of the land sharing landscape elements in just because of good economics as well. So, typically things like hedgerows, but then also design patches of forest that carry the specific predators for particular pests and so forth. But here we are currently, the science is not good enough in order to support the land sparing, the land sharing sites. So here I do hope that with more and better informed science, all the way to pesticides in food and so forth. I think we need to know much more what all of these is the current way to produce what it all does. I'm currently very fascinated by the entire microbiome discussion, where you link, the microbiome of the soil is actually directly linked to the microbiome in your gut, and the gut conditions your happiness and make also conditions basic decision making. So once we start to explore more of these values of more responsible and better agriculture, we'll actually only then we get more of the land sharing kind of elements, which are indisputable, absolutely necessary and helpful. One other observation is there's more or less with all of at least researchers I know of, everyone says yes, there's land sparing, land sharing, but in reality there is the truth is somewhere in the middle, and the truth in the middle is always highly contextual. So it really depends on in which landscape you are. And it's also scale dependent. So in the sense that, if we just create agro-industrial deserts, that's also not very sustainable either. Good. So with this, I would like to close my talk, and I would just urge everyone bringing more of scientific evidence to the table. And discuss facts over these highly ideologically loaded discussions that are associated with land sparing and land sharing. Thank you very much.
Thank you, Michael. Thank you very much for this really impressive presentation, holistically looking at the full picture of the analysis and also bringing in the ideology and bringing in politics. That's really, really nice. And beyond this, we are also highly interested in the technical part of machine learning and how you did it, but we can also discuss this later. I myself don't want to put me in the first place here.